Alright, you buggers. Swoosh, Polarith credit pretty sick, eh?
Hey everyone, and welcome to our very first video tutorial in which I'm going to take you through the basics of our AI. My name is Christian, and I am the content producer at Polarith, and I am very happy to have you here. I'm going to explain you how our comprehensive software works. We will focus on the principle of context steering and how you can benefit from its advantages by using our plugin. By the end of this video, you will be able to set up an autonomously moving agent in less than 1 minute. Furthermore, you will understand the basics of context steering and why it is so much better, as it makes your AI more natural than previous approaches. Of course, you are able to extend the system to your needs, but it is not required to write extra code at all. Let's talk about the organization of our components. All Polarith components are named with the prefix AIM, which means AI for movement. This makes it easier to find them. They are collected and organized in the component menu, and don't worry, you will be more familiar with the component categories at the end of this. Besides, we provided some useful links in the description to our documentation if you want more details. Okay, let's start. Imagine you have a non-player character which has to move on its own collecting some items. There are good items like health and mana potions, and there are bad items like traps. We want our character to collect only the good and interesting items while avoiding the bad, dangerous ones. We've already prepared a scene like this. The interesting object is portrayed in green, the dangerous one is red, and our character is colored in blue. The centerpiece component of our software is AIMContext. All required aspects for the usage of context steering are integrated within this one component. So let's add AIMContext to the character. Let's ignore the more advanced parameters for now, since the default values are fine. For now, we will only focus on two major aspects of context steering: a sensor and our objectives. A sensor is used for sampling the environment around the agent. For that, it consists of many feelers we call receptors. Like in the real world, a receptor is used for gathering information. Therefore, every receptor is characterized by a position and a direction. In simple terms, we can decide which direction is bad and which one is good with the help of the receptors. Okay, as you can see, the context already warns us that a sensor is missing. By using the given package, you can either use one of our predefined sensor assets, or you can create your own sensor asset via the context menu. We will create a new one where the receptors with the directions are arranged in a way forming a circle shape beginning from the center. The circle shape has the advantage that the directions are uniformly distributed over 360 degrees, and so every possible planar movement direction is covered. Moreover, the number of the receptors have a direct impact on how accurate the sampling is. Quite obvious, isn't it? The larger the number of the receptors, the more accurate the sampling. Now, we define a circle sensor with a receptor count of 16. So currently we have just set up a sensor for gathering information. But which information is really important in order to make the right movement decision? Let us remember, our character has to collect green items while avoiding the red one. These are two criteria independent of each other. One for seeking green items and one for avoiding red items. These criteria are also called objectives. With help of the objective values, our system utilizes multi-criteria optimization to obtain the movement direction which fits the current situation best. Let's add two objectives. We assign labels to the objectives for identifying them later on more easily. Of course, we want a solution where the interest is high and the danger is low. This can be specified by the first column. Therefore, we maximize our interest and minimize the danger. The second column defines whether the objective values should be normalized or not. Most certainly it is much easier to work with the normalized values instead of the original one. That's why normalization is true by default. With the last column, we can determine which objective is restricted by a constraint and which one is not. Constraints can be used for rejecting objective values. If the objective is to be minimized, again, this specified by the first column, all objective values are rejected lying over the given constraint and vice versa. We want to assign the constraint to the danger objective and let the interest objective unconstrained. As a result of the normalization, all values are lying between 0 and 1. So let us use a value of 0.4. Great. Let's summarize the current setup. We have assigned a circle sensor with a receptor count of 16 for sampling the environment and added two objectives, one for seeking interest objects and one for avoiding danger objects. Now, let's press the play button and take advantage of our visual debugging tools. By enabling the indicator, three circles are displayed. The first one represents the sensor with its receptors and their direction. The other two circles represent the objective values for each objective. You may notice that currently nothing is visualized inside the circles because the objective values are 0. One major part is missing, a behavior. In order to write objective values in our context map, behaviors are required. From a designer's point of view, you could still think of a behavior as something that defines how an agent has to move differently in certain situations. So a behavior controls the movement of the agent by writing objective values. Okay, let's attach our first steering-like behavior AIMSeek via the component menu. In the Seek inspector, we see a bunch of parameters, but don't be afraid. The default settings are fine. There are only two parameters we should focus on. The target objective determines the objective for the behavior to write its results. Thus, we assign interest. The next thing we need to do is to tell the behavior what it should perceive. Because this behavior has to write values for interest, it should only perceive interest game objects. This can be set in the Environment tab. There are two different ways for transferring the game objects. You can either set the game objects directly or use our perception pipeline. By using our perception pipeline, you can use Unity's layer system for grouping thousands of game objects with only one click and making them available to our behavior. But in order to focus on context steering, we will set the game objects directly and explain our perception pipeline in another video tutorial. In addition, you can find a detailed section about the perception pipeline in our documentation. Okay, let us assign our first game object to our Seek behavior. Now there are non-zero values for the first objective. The orange line indicates the current decision. This can be processed by a movement controller. You may notice that the Seek behavior writes objective values towards the direction pointing from the agent to the interest game objects. We can observe this by moving the agent. Currently, the second objective is not considered, and so the result direction points through our danger object. In order to change that, we just need to attach a second Seek behavior. Set the target objective to danger and assign the corresponding danger object. As you can see, the orange line points towards a direction for avoiding the red danger object, while still pointing towards a direction that quickly leads to our green interest object. Of course, if there's no red danger object between the agent and the interest object, our character would move directly towards the interest. Last but not least, we need something for transforming the resulting direction into movement. Usually this is done by a controller. We provide two different kinds of controllers for 2D and 3D. A simple controller where the character's movement direction matches the output direction immediately, and a physics controller where the result direction is applied via a force to the rigid body of the character. Now we use the simple controller so that we can study the output direction better. For further understanding on how to implement your own controller, consult the manual. Let us now add the simple controller 2D. After avoiding the red danger object, the agent is moving towards the interest object directly. Let's play around with the object positions. You will notice that the agent moves very odd. This is due to the low receptor count and the nature of a direct controller input. For a smoother movement despite the low receptor count, we recommend adding the AIM planar linear interpolation behavior. This improves the solution found by the agent and is more efficient than adding more receptors. In order to prevent strong variation of the resulting direction over frames, we recommend attaching AIM stabilization. This behavior adds interest along the direction of the last decision. We can now observe a smoother movement of the agent. Finally, we know that the correct setup of an agent is not done with only one click. Or is it? It is. The steps you've just seen in this video can be done with just 3 clicks by using our wizard in the AIMContext component. Let's clear the current agent and use the wizard. Just create a default sensor and a default agent and assign the game objects to our behaviors. Note that if you're using a physics-based controller, you possibly won't need smoothing at all. Now feel free to experiment with our behaviors and the sensor system. There are more than 20 inbuilt behaviors, for example to follow different objects, to create swarming situations, squad leader scenes and much more. If you want to go more into detail, we also recommend reading the quick start chapters in the manual. Of course, we provide an extensive and easy to read general documentation as well. That wraps it up for this video. Looking forward to your work with our AI and see you in the next one.
And now everybody listen up. Get to the store and buy that shit. Maria, me a sandwich.